Assalamualaikum and good day everyone. Today, we will be presenting our project for penetration testing titled Firewall Configuration and Secure System Design using IP Tables. These are my group members, and this project demonstrates how IP tables can be used to block insecure services, analyze firewall behavior, and improve overall system security. So, let us begin.
What is a firewall? A firewall is a security system that controls incoming and outgoing network traffic. It acts like a gatekeeper, deciding which data is allowed to enter or leave a computer or network. Just like a security guard checks people entering a building, a firewall checks network traffic. The main purpose of a firewall is to protect system from unauthorized access, attacks, and malware. It helps prevent hackers from accessing sensitive data and ensures only trusted traffic is allowed. Types of firewalls. For the first one is network-based firewall. A network-based firewall protects an entire network. It is usually placed between the internal network and the internet, such as in routers or dedicated firewall devices. Examples we can use in companies or organization. Second is host-based firewall. A host-based firewall protects a single computer or server. It runs directly on the operating system. For examples, Windows firewall and also Linux IP tables. IP tables is used in Linux because it is very powerful, flexible, and built-in. It gives full control over network traffic and allows users to create custom security rules. There are main reasons. The first one is comes pre-installed in most Linux system, highly configurable, supports packet filtering, NAT and port blocking, and also commonly used in servers. In summary, firewalls are essential for network security, and IP tables is an important firewall tool used in Linux system to protect computers and server.
Importance of network security. Today, network security is extremely important because cyber threats are increasing rapidly. Many systems are constantly connected to the internet, making them easy targets for attackers. If services like HTTP, FTP, or Telnet are left unsecured, attackers can exploit them to gain unauthorized access. A firewall helps control which traffic is allowed or blocked, reducing this risk. Therefore, network security is essential to protect sensitive data, system availability, and overall system integrity. The main goal of this assignment is to understand how IP tables functions as a host-based firewall in Linux systems. We aim to configure firewall rules that block insecure services such as HTTP, FTP, and Telnet. Another important objective is to analyze the difference between drop and reject actions. We also test the firewall rules using tools like Telnet, curl, and Nmap to verify their effectiveness. Overall, this assignment helped us gain practical skills that can be applied in real-world security scenarios.
Assalamualaikum, nama saya Nur Aida Akmal binti alias nombor matrikku 17884. Saya akan teruskan pembentangannya dengan IP tables installation and status verification. Okey, objektif utama adalah untuk block tree service iaitu HTTP port 80, FTP port 21 dan Telnet port 23. First sekali, saya cek versi IP tables menggunakan command IP tables /version. Output menunjukkan IP tables version 1.8.11 dengan NF tables, which means IP tables tu dah diinstall dan aktif pada sistem ni. Ia juga menunjukkan sistem menggunakan Linux Firewall Framework yang lebih moden. Seterusnya, saya display firewall rules yang sedia ada menggunakan command sudo iptables -l-n-v. Pada peringkat awal, input dan output chain diset kepada accept. Maksudnya, semua incoming dan outgoing traffic dibenarkan. Manakala forward chain diset kepada drop, yang biasanya digunakan untuk routing dan local traffic. Pada masa ni belum ada rule untuk blok HTTP, FTP atau Telnet. Seterusnya untuk firewall rule design, saya perlu blok HTTP pada port 80, FTP pada port 21 dan Telnet pada port 23. Action reject digunakan untuk HTTP supaya pengguna terima maklum balas yang jelas yang servis tersebut tak dibenarkan. Manakala action drop digunakan untuk FTP dan Telnet sebab servis tu lebih berisiko dan sesuai untuk pendekatan stealth security, di mana sistem tak beri sebarang respon kepada cubaan akses. Okey, seterusnya IP tables rules configuration. First, saya blok HTTP traffic pada port 80 menggunakan action reject dengan command sudo IP tables -a input -p TCP di port 80 -c reject. Saya gunakan reject supaya klien terima error respon yang menunjukkan servis tu tak dibenarkan untuk diakses. Seterusnya, saya blok FTP traffic pada port 21 menggunakan action drop dengan command sudo IP tables -a input -p TCP di port 21 -c drop. Drop tu akan buang paket tanpa sebarang respon yang sesuai untuk tingkatkan stealth security. Kemudian saya blok pula Telnet traffic pada port 23 menggunakan drop sebab Telnet ni adalah satu protokol yang tak selamat sebab dia hantar data dalam plain text. Jadi saya gunakan action drop dengan command sudo IP tables -a input -p TCP di port 23 -c drop. Lepas semua firewall rules tu dah ditambah, saya verifikan balik menggunakan command sudo IP tables -l -n -w. Output menunjukkan yang semua rules dah berada dalam input chain yang mengesahkan yang firewall configuration tu dah berjaya dilakukan. Seterusnya berkaitan firewall rule persistence. By default, IP tables rules tak persistent, meaning rules tu hanya disimpan dalam memori. Bila sistem tu di-reboot, semua firewall rules akan hilang secara automatik jika tak disimpan. Jadi untuk ensurekan firewall protection tu remains active selepas reboot, rules tu mesti di-save dan automatically restored during system startup. Antara approach yang biasa digunakan adalah menggunakan IP tables persistent service yang di mana dia akan reload the save rules every time the system reboot. Alternatively, selain itu, firewall rules boleh juga di-apply menggunakan startup or boot time script so that configuration tu di-apply secara automatik. Maklumat tambahan untuk method yang pertama, persistent firewall service. Method tu suitable untuk production environment sebab ia ensurekan firewall protection tu remains active tanpa require manual reconfiguration. Manakala untuk approach yang kedua, using startup service, di real world scenario, especially untuk small businesses dan juga startup, firewall rule persistent tu penting untuk maintainkan continuous security dan juga untuk elakkan daripada accidental exposure of network service selepas reboot. So that's all from me. I will pass this presentation to the next presenter.
Okay, here I will explain about drop and reject. Okay, for number 1, I will explain the meaning of drop and reject. Drop is a firewall action where packets are silently discarded without sending any response back to the sender. From an attacker's perspective, the system appears unreachable or non-existent. Okay, then for reject, we'll block the packets and send an explicit error message such as a connection refuse response and back to the sender. Okay, this clearly informs the user that the connection attempt is not allowed. For number 2, this is the comparison between drop and reject. In terms of security, Drop provides a higher level of protection because it hides the presence of the system and makes network scanning more difficult. However, this comes at the cost of usability, as users may experience longer connection times out. While reject is more user-friendly because it provides immediate feedback to the sender. While this improves usability, it slightly reveals the firewall's behavior and system presence. Okay, conclusion, drop emphasizes stealth and security, while reject emphasizes usability and clarity. Moving on to number 3, which is security versus usability perspective. Okay, when configuring firewall rules, there is always a trade-off between security and usability. Using drop increases security by minimizing information disclosure but may frustrate legitimate users due to delayed response. While using reject improves usability by providing clear and immediate feedback, making troubleshooting easier. However, it slightly reduces security by confirming that the system is actively blocking traffic. Okay, therefore, the choice between drop and reject depends on the risk level of the service and the type of users accessing it. Finally, for number 4, I will explain the justification for each block service. Number 1, for HTTP on port 80, we applied reject. HTTP is a commonly used service, so reject was chosen to provide immediate feedback to users that the service is disabled. This improves usability while still maintaining security. Okay, number 2, for FTP on port 20, we applied drop. FTP is an insecure protocol because it sends credentials in plain text and is often targeted by attackers. Using drop will hide the service completely and reduce exposure to scanning and brute force attacks. Number 3, for Telnet on port 23, we also applied drop. Because Telnet is highly insecure due to the lack of encryption and is considered a high-risk service, drop was selected to fully conceal the service and provide maximum security. Okay, in summary, reject is used when usability and clear communication are important, while drop is used for high-risk services that should be hidden from attackers.
Testing and validation. Testing methodology. Firewall rules were configured using IP table on a Linux host. Testing conducted before and after firewall rules were applied. Service tests, HTTP, FTP, and Telnet. Service tool used Telnet for test remote service access, curl to test HTTP connection behavior, and map port scanning and service detection. Results were captured using command output screenshot for purpose to validate firewall behavior and to observe drop versus reject effect on connection. Before firewall testing, no custom firewall rules apply. All test ports were accessible. Service respond normally to connection item. Nmap scan show open port and Telnet and curl connection were successful. Observation, system exposed to insecure service and high attack surface due to unrestricted access. After firewall testing, IP table rules apply. HTTP 80 reject, FTP 21 drop, Telnet 23 drop. Unauthorized connection were blocked. Nmap scan show filter or unreachable port. Telnet connection fail as expected. Curl show immediate rejection for HTTP. Observation, firewall rule successful enforced, attack surface significantly reduced. Drop versus reject result. Drop behavior, no response sent to sender. Connection appears to timeout. System looks invisible to attacker. Observed in FTP 21 and Telnet 23. Reject behavior, immediate error message return. Sender inform, connection is not allowed. Observed in HTTP AT. The result, different firewall action produce different network behaviors. Firewall effective, insecure service successful block, drop rules improve still security, reject rules improve usability and feedback, firewall work as a host-based security control, testing provide rule function as designed. The conclusion, first, firewall implementation effectively balance security and usability. The last one, demonstrate real-world firewall behavior using penetration testing tools.
Let's begin by identifying the cybersecurity challenges across different sectors. In homes, we see issues like default router settings, weak password, and insecure IoT devices. Startups often scale rapidly, overlooking security, leading to cloud misconfiguration and compliance gaps. SMEs struggle with limited IT staff, outdated protection tools, and are highly vulnerable to phishing and ransomware. These gaps aren't just threats, they are opportunities to deliver simple, affordable, and effective security solutions. One such solution is the iptables firewall. It's rule-based, adaptable, lightweight, and open source, making it cost-effective. But here's the entrepreneurial twist. We can bundle this technical tool into user-friendly packages for non-technical users. The mindset here is key, transforming complexity into simplicity that solves real pain points. Let's talk value. Affordable protection lowers barriers for SMEs and startups. It builds customer trust, which becomes a competitive edge, and it reduces downtime, saving both money and reputation. The impact? Businesses can grow without fear of cyber threats. It also opens doors to new ventures like consulting and managed services. Scalability is crucial. With cloud-based management, we enable remote deployment. A subscription model ensures recurring revenue. Modular add-ons like VPNs and IDS enhance flexibility. Innovation drives us forward. AI-driven rule updates, simple dashboards for non-tech users, and community-driven improvement keeps us ahead of evolving threats. In summary, we've identified real security gaps and proposed a practical, iptables-based solution. It's secure, affordable, and adaptable, with clear business value and impact. Our roadmap is scalable and innovative. This is the entrepreneurial mindset in action. Spot problems, design practical solutions, scale with innovation, and turn challenges into sustainable growth opportunities.
That's all from us. Thank you.